Welcome back to Chemical Engineering Education. Today we are diving into one of the most fundamental tools every chemical engineer must master, that is mass and component balance. What if I told you we could solve this problem faster and more accurately than ever using Python and symbolic algebra? Let's begin with a basic example. Two water stream enter a mixing unit. So stream 1 3 kg per minute, stream 2 2 kg per minute. We consider it is a steady state process. So what will be the total mass flow rate at the output? So we know from the mass balance principle, input is equal to output. So if I do that, input is equal to output. So here using Python, so very simple, given input stream. So stream 1 is equal to 3 kg per minute and stream 2 2 kg per minute. So total mass flow rate will be output is equal to stream 1 plus stream 2. If I run that, so I'll get total mass flow rate means output 5 kg per minute. So that is very straightforward. Now let's level up. So for this, now imagine we are mixing ethanol and water into two feed stream. So stream 1, so 100 kg per hour, and here in 30% ethanol is there, and stream 2 200 kg per hour. So in that stream 2 60% ethanol is there. So now if I mixed that two stream, what will be the output and what will be the percentage of ethanol? So our goal is find the output flow rate and ethanol concentration using mass and component balance. So now here we can write that mass and component balance equation. So total mass balance F1 plus F2 is equal to P. So here F1 is the mass flow rate of the stream 1, F2 is mass flow rate of stream 2, and product stream flow rate is P. And ethanol component balance, so F1 into X1, F2 into X2 is equal to P into XP. So X1 is the mass fraction of the ethanol in stream 1, X2 is mass fraction of ethanol in stream 2, and XP is the mass fraction of ethanol in product stream. So now here we set up two equations, one for total mass balance, another is ethanol mass balance. So now here we will use SymPy to solve the total output flow rate and ethanol weight percent in the output. So for that we are from SymPy we are importing symbols and then symbol equation and solve. So here given values, F1 is given 100 kg per hour, X1 is given, F2 is given 200 and X2 is 0.60. Okay, now here that two unknowns, so that is P means total product and XP, that in that product the ethanol concentration. So these are the two unknowns. Now here I am setting that two equation. So total mass in is equal to total mass out. So equation 1 is equation F1 plus F2. So this is input and this is output. Similarly component balance. So this is ethanol in. So F1 into X1 plus F2 into X2, and this is the product side ethanol. Now if I solve that solution, solve is the function we call that. Okay, now if I do that, so we'll get the solution. So P value and XP value. So now if I run that, already it is there. So now clear the output. Now if I run that, we'll get the total flow rate P 300 kg per hour and ethanol weight percent in product 50%. So final answer is total output flow rate is 300 kg per hour and ethanol weight percent is in output 50%. Now we can change here. So we can change and we can do many calculation. So now here if I change that, then my things will automatically change. So now from this using SymPy we solve that system symbolically and our result we got that. So now mass, you know that mass and component balance are the backbone of the chemical engineering, and tools like Python make them transparent, repeatable and faster. If you found this video is helpful, hit the like button and don't forget to subscribe to my channel Chemical Engineering Education for more process modeling, Python coding and simulation content. Thank you.